Good morning, friends. We have already started chapter number 5, that is process control. And yesterday we have discussed about process creation with the help of fork system call. Now today we'll discuss about second point from the chapter, that is signals. So what is signals? Signals is nothing but the indication. Like we are good familiar with traffic signals. So in case of traffic signals, red indicates that you have to stop. Green indicates that you can start your process, like that onwards. So that is nothing but signal is a indication. So in case of operating system, signals are used for inter-process communication. For what purpose signals are used? For inter-process communication. So in Unix, there are total 19 signals, and these 19 signals are categorized into 7 categories. So under signal point, we'll discuss about the points, classification of signals. Then we'll discuss about algorithm for recognizing the signal, that is name of the algorithm is PSIG. Then we'll discuss about handling signals. Under handling signals, we'll discuss about signal system call, and then we'll discuss about the algorithm for handling the signal, and name of the algorithm is PSIG. Then we'll discuss about the concept of process groups. Under process groups, we'll discuss about the concept of set PGRP system call, and at last we'll discuss the point sending signals from processes using kill system call. So these are the total 5 points which we are discussing under the point signals. So we'll see one by one. So first point is nothing but the classification of signals. So there are total 19 signals in Unix system, and these 19 signals are categorized into following categories. So first category is signals having to do with the termination of process. So whenever in Unix, whenever any process want to terminate, so that process sends one signal, and name of that signal is death of child signal, to its parent process. So this is nothing but signals having to do with the termination of process. Second, signals having to do with process induced exceptions, such as when a process accesses an address outside its virtual address space. So if we are generating any wrong virtual address, so in that case exception occurs, and that is nothing but signals having to do with process induced exceptions. For example, suppose if we have declared the array of size 5, that is int a of 5, and if we are trying to access the element a of 6, so a of 6, it is not existing elements. So how many elements will be there in this array? A of 0 to a of 4, that is total 5 elements will be there. And if we are trying to access a of 6, so it indicates a wrong virtual address. So this is nothing but the signals having to do with process induced exceptions. Third category, signals having to do with unrecoverable conditions during system call. So during system call, sometimes some of the unrecoverable conditions will be there. So in that case, such signals are induced. For example, EXEC system call. So system resources during EXEC after the original address space has been released. So in case of EXEC, we are able to execute other program by using the current program. So if we are executing other program, and if the resources are not available for that other program, so such signals will be sent from other program to the current program. So this is nothing but signals having to do with unrecoverable conditions during system call. Next type of signal is signals caused by an unexpected error condition during a system call. For example, we have discussed about L6 system call, and in case of L6 system call, we have discussed about the third parameter passed to the L6 system call, that is reference. So actually reference value should be either 0, 1 or 2. So what is the purpose of L6? So we are able to set the file pointer. So if we are setting the value of reference as a 0, so it indicates that it considers from the start of the file. So 1 indicates from the current position of the cursor and 2 indicates from the end of the file. So instead of these values 0, 1 and 2, if we write any other value, say 3, 4, 5, so it indicates the illegal reference. It indicates the illegal reference. In short, to the L6 system call, so only three reference values we are able to pass, either 0, 1 or 2. So then these values, if we are passing any other value, any negative value or any other value 3, 4, 5 like this, so in that case, so unexpected error condition may occur. So in that case, kernel takes the help of such type of signals. So next type of signal is signals originating from a process in user mode, such as when a process wishes to receive an alarm signal after a period of time, when processes send arbitrary signals to each other with the kill system call. So this is nothing but signals originating from the process in user mode. So best example is of alarm signal. Next type of signal is signals related to terminal interaction, such as when a user hangs up a terminal. This is nothing but the signals related to terminal interaction. So if we are writing abort on the terminal, so terminal will be get hanged. So this is nothing but the signal related to terminal interaction. And the last type of signal is nothing but signals for tracing execution of a process. So internally, in case of Unix, there are some of the signals which are tracing the execution of a process. So these are the total 7 categories of signals. So this is nothing but the classification of signals. So after classification, we'll discuss about algorithm for recognizing a signal. We'll see algorithm for recognizing a signal. Before that, so if you are looking towards this diagram, so in the process state transition diagram, so here they have shown, so when there will be the state transition from kernel running to user running or from preempted to user running, so here it is written check and handle the signal. So kernel processes checks the signals as well as handles the signals only in these two types of transition, that is kernel running to user running and preempted to user running. In case of other state, it will not handles the signals or it will not checks the signal. So this is nothing but checking and handling signals in the process state transition diagram. So sometimes this question may be asked. So draw a state transition diagram and show where the signals are checked and handled. So same diagram which we already discussed, just you have to show during these two transitions, that is kernel running to user running and preempted to running. So you have to write check and handle the signals. So this is nothing but checking and handling signals in process state transition diagram. Now come to the point, algorithm for recognizing the signal. So name of the algorithm is PSIG. So with the help of this algorithm, kernel is able to recognize whether there is signal or not, whether the process has received signal or not. So this work is done by algorithm PSIG. So input to this algorithm will be none and output will be two types of outputs will be there. Either the output will be true if process receives signals that it does not ignore, and it will be false otherwise. So process is unable to ignore the signal. In that case, process have to compulsorily receive the signal. So three ways of handling the signals are there. Either process is able to ignore the signal, either process is able to terminate itself, or process have to handle the signal. So which are these three ways? Three ways, that is either the process is able to ignore the signal, or process is able to terminate itself after receiving the signal, and at last if it is unable to terminate and unable to ignore, so in that case process have to handle the signal. So that's why output of this algorithm is true if the process receives signal that it does not ignore, and will be false otherwise. So come to the body of the algorithm. While received signal field in the process table entry is not 0. So recall, in process table entry, that is under process table, we have discussed about total 8 fields, and one of the field is signal field. So in that signal field, either the value 1 or 0 will be there. So 1 indicates that process has received the signal and 0 indicates that process has not received the signal. So here we are checking the field in the process table entry. So if received a signal field in process table entry not 0, so not 0 indicates that it may be 1. So 1 indicates that process has received the signal. So what kernel does, it finds the signal number sent to the process. Are you getting my point? That is, in the process table entry, either the value will be 1 or 0. So if the value will be 0, it indicates that signal is not received, and if the value will be 1, it indicates that signal has received. If the signal has received, kernel have to check the signal number sent to the process. If signal is death of child signal, so out of 19 signal, one of the signal is the most important signal, that is death of child signal. So it checks whether the signal is death of child process or not. So if the signal is death of child process, what it does, it checks if ignoring death of child signals. So sometimes parents, they are ignoring the death of child signal. So in that case, so if it is ignoring, so it frees the process table slot. If it is ignoring the death of child signal, it frees the process table entries of zombie children as the child is going for termination. So it immediately frees the process table entry for the zombie children. And else indicates that not ignoring death of child signal. It means parent process have to handle the death of child signal. So it want to catch the death of child signal. So in that case, it want to handle the signal. So in that case, it returns the value 2. So as we have seen, output of this algorithm will be either true or false. So when it will be true, if process want to handle the signal, and when it will be false, if process don't want to handle the signal. Now come to the else part. So else part indicates that signal is not death of child signal. So it may be any other type of signal. So in that case, it checks if not ignoring signal, it returns 0. So if process don't want to ignore the signal, it returns it returns true. It means it want to handle the signal. Otherwise, turn off signal bit in received signal field in process table. So see the most important last line, turn off signal bit in received signal field in process table. So in the process table, the signal bit is set to 1. So 1 indicates that signal is received by the process. So same signal may be received by the process more than once. For example, if we are traveling, so in the first chowk, we may receive the red signal. After some time, we may go to the second chowk, and there also we may get the red signal. It means we are receiving the same signal more than once, and every time that signal bit should be set to 1, indicating that signal has received, process has received the signal. So for that purpose, the last line is there, turn off signal bit in received signal field in process table, and at last, otherwise it returns the false. So this is about algorithm is SIG. So if the received signal field in the process table entry is not 0, then only it thinks about handling the signal. In that case only it returns true, otherwise it returns false. Is it right? So this is about algorithm for recognizing the signal. Now come to the next point. So next point is nothing but the handling the signal. So in case of Unix operating system, signals are handled with the help of signal system call. So if you are looking to the syntax of signal system call, old function is equal to signal number function. So signal number is nothing but the signal which is received, and function is nothing but the function which is performed by the process to handle that signal. For example, if we receive the traffic signal red, so what kind of function we are performing? We are stopping. So this is nothing but the function. So function may be user defined or function may be system defined. So two types of functions are there, user defined function and system defined function. So in case of our traffic signal, so system defined function says that after receiving the red signal, you need to stop. So this is nothing but the system defined function. So this is the function defined by the government. And what do by user defined function? So if we came to know that we have to wait, more big traffic is there and we have to wait maybe for 10 to 15 minutes. So what we'll do, So instead of waiting over there, so we may go to the nearby shop and we may do some kind of shopping, and whenever signal will be breaked, then we have to start our operation. So this is nothing but the user defined function. So function may be user defined or system defined. So this is nothing but the syntax of signal system call: signal, signum and function. And after that it returns the old function. So this is old function is nothing but the output, that is signal is handled, that particular signal is handled, particular function is get executed. So this is nothing but the signal system call. And now come to the algorithm, that is if process want to handle the signal. So just now I said that there are three ways of handling the signal: either process can ignore the signal, or process can handle the signal, or process can terminate itself without listening towards that signal. So out of that, the one major way is nothing but handling the signal. So if we are unable to ignore, if we are unable to terminate, so in that case compulsorily we have to handle the signal. And to handle the signal, kernel takes the help of PSIG algorithm. Now look at to the PSIG algorithm. Input to this algorithm is none and output is also none, that is signal will be get handled. So next come to the body of the algorithm. Get signal number set in process table entry. So it gets the signal number set in process table entry. So which signal number is received by the process, so that will be taken from the process table entry. Clear signal number in process table entry. So as signal in process table entry is set to 1, indicating that process has received the signal, we have to clear that signal field, because in future process may receive the same signal. So again kernel have to make that value as a 1. So that's why it is cleared. Next, if user had called signal system call to ignore this signal. So if user want to ignore the signal, it returns. It doesn't do anything because it don't want to handle the signal. So at the time of handling also it is able to check whether user had called signal system call to ignore the signal. Otherwise, if user specified function to handle the signal. So now the second if loop is most important. So user want to specify the function, that is process want to handle the signal. So in that case what it does, get user virtual address of signal catcher stored in U area. So again come to the part of U area. So in process table either the value will be 1 or 0, and the signal field in U area, what is stored inside that? So inside that the address of signal catcher, that is after receiving the particular signal. So each signal is having its own signal catcher, like each interrupt is having interrupt handler. In the same fashion, each signal is having its own signal catcher. So signal catcher is nothing but the function, and address of that function is stored in U area. So U area is the data structure where the current data about the running process is stored. So what kernel does, it gets the virtual address of the signal catcher which is stored in U area, and after taking that address again it clears the U area entry, that stored address of the signal catcher, and after that it modifies the user level context. So artificially create user stack frame to mimic call to signal catcher function. So it creates one more user stack for the signal catcher to catch the signal function, that is to execute the signal function, and at the same time it modifies the system level context, and in system level context it writes address of the signal catcher into program counter field of user saved register context. So listen carefully over here what it is doing. So it is switching from the current process to the signal catcher. So what is signal catcher? Signal catcher is nothing but the function. So after receiving the signal, it want to handle the signal, and to handle the signal it have to execute the signal catcher. So that's why now program counter should store the address of the signal catcher, because over here context switch is going on. So processor is get switched from the current process to the signal catcher. So that's why the program counter will be get changed. The register level context will be get changed, and after that return. And next, if signal is type that system should dump core image of process. So sometimes process has decided to handle the signal, but some of the files may be corrupted which are required to handle the signal catcher. So it has decided to execute the signal catcher, but if some of the files related to signal catcher are already corrupted, so in that case again system is unable to handle the signal. So in that case what it does, it creates file named core in current directory and write contents of user level context to the file core. So sometimes we are receiving the message, so system will shut down, or we are receiving the message tc.exe file is corrupted. So these are nothing but the messages which are coming from the core file. That is, we have tried to execute the tc.exe file, but at the time of execution we came to know that this file is corrupted. So such type of signals are also handled with the help of core image of a process. And at last, invoke exit algorithm. So what do you mean by exit algorithm? That is, here it is trying to handle the signal. It means from the current process, so it is going to the signal catcher, and after execution of the signal catcher, again it is coming back to the process. So in that case, it have to execute the exit algorithm, so that the processor will be switched from the signal catcher to the previous process. So this is about handling the signal, algorithm for handling the signal. And now come to the next point, that is nothing but the next point from the signal point is process groups, the concept of process groups. So like process, each process is having its own PID. In the same fashion, number of processes are coming together to form a group. So such process group is also having its own unique ID, and to set that unique ID to the process group, so kernel takes the help of set pgrp system call. So with the help of set pgrp system call, the group ID will be set, and with the help of get pgrp system call, so the process group ID will be getting. So this is the system call which is used in case of process group. And why the concept of process group is coming over here? So process group, that is number of processes they want to discuss with each other. They want to do the inter-process communication. So for that purpose, the concept of process group will be there. And the last point from this signal field, signal point, is sending signals from process. And processes, they are sending signals to each other with the help of kill system call, which we have already discussed in the first experiment, the small assignment we have taken. And over there, that is, we have started multiple processes and we have stopped the processes as well as we have resumed the processes. So the syntax of kill system call is PID, sig number. That is, to which process we want to send the signal. So sig number is nothing but the signal number which we want to send to the process, and that process is identified with the help of PID number. So based upon this syntax, so over here PID identifies the set of processes to receive the signal, and signal number is the signal number being sent. The following list shows the correspondence between values of PID and sets of the processes. So based upon the value of PID, so signal will be sent. If PID is a positive integer, if the PID is positive integer, kernel sends the signal to the process with process ID PID. So what kernel does, if PID's value will be any positive number, so it indicates that signal is required to be sent to that process. Next, if PID is 0, the kernel sends the signal to all processes in the sender's process group. So again, sender's process group will be there and receiver's process group will be there. If the value of PID will be 0, so what kernel does? So kernel sends that signal to all the processes in the same process group. Got it? And next, if PID value is -1, kernel sends the signal to all processes whose real user ID equals to the effective user ID of the sender. We already discussed real user ID and effective user ID. Real user ID is responsible for current execution of the process, and effective user ID is the owner of that process. So if the value of PID is -1, kernel sends the signal to all processes whose real user ID equals to the effective user ID. And the last one, if PID is negative integer but not -1. So in that case, kernel sends the signal to all processes in the process group equal to the absolute value of PID. So absolute value of PID, that is nothing but, we don't consider any negative sign. So we are considering the only magnitude only. So that is nothing but the absolute value of the PID. So these are the different cases in case of kill system call. And finally, with the help of kill system call, we are sending the signals from the processes. Like thus, we have completed the signal point, and under signal point, we have discussed about the points classification of signals. So total 19 signals classified into 7 groups. After that, we discussed about algorithm for recognizing the signal. Algorithm is SIG. Output of the algorithm will be either true or false. So true indicates that process want to handle the signal. False indicates that process don't want to handle the signal. So after recognizing the signal, if the output will be true, then only we are going for handling the signal, and the signal is handled with the help of algorithm PSIG. And after that, we discussed about the concept of process group and sending signals from processes with the help of kill system call. So this is about signals. This is the second point from this chapter which we have completed today. We'll stop here.